Hi there, welcome to the webinar. My name is Kevin Lynn from engineering.com, and with us today we have Sergio Brickhouse, who's one of EPLAN America's lead application specialists and an avid EPLAN evangelist. He has been preaching the EPLAN word for more than 8 years now. His goals are to make others enjoy EPLAN as much as he does. Sergio, glad to have you with us today.
Thank you, and thank you everybody for joining us today. So today's webinar is going to be on how to easily automate your electrical design processes. So one of the few advantages that we're having right now, EPLAN has this design methodology concept, and what does that entitle? So what we're trying to find ways is to making users out there understand how to better do their processes and their design operations and functionality, and also benefit from the tools that EPLAN has to offer. One of those is the use of proven library modules in error-free design. So what we're trying to do is we're trying to really make sure that everybody has a standardized functionality, a standardized library of different products or different options available that they can benefit from using and reusing. We're trying to minimize individual engineering and reduce project design time. Also, the independence from the know-how of a design engineer. What we're also trying to do is to automate the creation of engineering documentation and reduce project design time, with actually adding a huge flexibility due to the individual configurations. Here, just change the slide. So how is engineering done today? This is one of the biggest questions that we have to ask a lot of our listeners out there. Is shorter time and lower cost and higher quality possible right now, the way that you're proceeding? So one of the biggest questions also that we have is, how is it in your company right now? What are the procedures that you're taking on right now in order for you to create your products, the documentation, everything it entitles? So to explain these questions further, we have different requirements that we formulated from different companies, and we can always, trace them back to 3 different criteria. One of those criteria is time, the other one is cost, and obviously the last one is quality. So in the course of the presentation, each of these 3 criteria will be described, where the vulnerabilities lie in today's engineering processes, and how it is possible through the approach of functional, modular-based engineering to make significant improvement with respect to all of these 3 criteria. So what are the market requirements right now that we're living on a day-to-day basis? So one of those market requirements, of course, is the external demands that we have for each project phase. One thing that a lot of our customers are requiring from us is, ideally, we should be able to produce faster products. We should be able to produce cost-efficient products. So everybody is looking at their pockets and making sure that, hey, I only have so much to spend, and I want to make sure that everything fits in the mold here. Higher quality, of course. This is just, I guess, a common human psychology that we're looking for all these questions, right? One of those other external demands is the use of new technologies. We're in 2016, soon anyway. We have a lot of cloud-based technology. We have a lot of, highly capable equipment, hardware. We have the internet is getting a lot more faster and more robust. So the use of new technologies, of course, is going to be a demand that is upon us to basically, have some customers' satisfaction in this case. And obviously, the quick reaction of customer requirements. This is one of the biggest key issues that we see in a fundamental when you're creating a project. A lot of customers want you to make modifications and changes, and they don't want to wait 2-3 days or months or however long it takes you to make these changes. They want the fastest reaction time as possible. So right now, what are the current established internal processes in all project phases that we're commonly living in here in North America and pretty much everywhere in the world? One of those is obviously the use of all their data and projects. So we have some projects that we've done in the past. They kind of look similar, and what we have a tendency of doing is making sure, oh yeah, I worked on this project a couple of months ago. It looks similar to the one I'm working on right now, so I'm going to use my copy-paste function. So the copy-paste function is a very commonly used practice in engineering and in design that we use. One of those issues also that we right now, or the processes right now that exist in place, are the manual editing of information and documentation. Of course, when we're using a copy-paste type of functionality, manual editing comes into play. So we've made a copy, we've pasted into a new project, but the data, of course, is not necessarily similar, is identical. So we're going to go into our established tool, and we're going to start to make some changes in this tool manually, of course. So this is something that is a common current established internal processes right now. And of course, no standards. So here in North America, from the experience that I have so far, we are technically following a certain rules and certain standards, electrical codes and so on and so forth, which everyone does, and everyone has their own opinion about the electrical codes and standards in place in their own place of work. But in retrospect, when we start to really dig deep inside these projects and how they're being created, technically there's no real set standards. So we're just using hybrids of standards that we learned through our experience, or maybe standards that we were applied or imposed by the company that we're working for. Obviously, if we switch jobs and we go to another company, we have to relearn a new set of standards because that's the way that they were doing it for like the past 20 years. So this is something that is what we have to live by right now that we're actually going through. So here we have an example of the current situation of reusability. So we have here a project 1, we got a project 2 we got to do, we got some sections of project 1 that we're going to use in project 2, then we're going to create the continuation of project 2, we got a project 3 that comes along, and we're going to use some elements of project 2 in our project 3. We're also going to use some elements of project 1 into project 3, and therefore we're going to add some additional new information or new data into our third project, which will, of course, we will eventually spit out to the next projects that are coming around. So one of the key issues to understand about reusability is that we have a lot of customers that come up to us and say, oh, you know what, I have a one of, every single project that I make is completely different and no projects are identical and all this good stuff. But if I'm looking at a schematic sheet, if I'm looking at a distribution page, if I'm looking at a drives page, if I'm looking at a PLC card or additional electrical schematics, they don't change. Physically and visually, they don't change. A relay is a relay, a PLC card is a PLC card, but what happens is that the data within inside those elements changes. So if it's a relay from a particular company or maybe a different relay from an additional company, amperage, voltage, technical data will change. Visual data, or what we see on print, does not really get changed that much. Okay, so a distribution page is a distribution page and so on and so forth. So that's what we're talking about here, the reusability. And this is exactly the processes that everybody right now is using right now and is in place in their companies. And this is with this diagram, we're demonstrating exactly what we're talking about, is that project 1, project 2, project 3, they're all pretty much a mishmash of copy pasting into one another. What does this cause? This causes errors. One of the biggest issues right now that people have mentioned to us is that when they're doing a copy pasting, well, if you had an error in project 1 and you copy pasted it into project 2 and 3 and 4, that error probably was missed and was not really verified or checked, and therefore that error gets transferred over to all the different other projects. We also have boring manual work, which is error prone. So if I copy the segment from project 1 to project 2, and of course I'm doing some manual editing to change the amperage of a relay or the horsepower of a motor, but I forget certain information, this could cause issues in the future projects to come. Time-consuming engineering, because what happens is when we're doing these functionalities of copy pasting and getting information from older projects, we're spending all this time to find these older projects to figure out where did I see that section that I need right now in my project 2, and once I find it, I have to test it. I have to make sure that everything is clean and everything is going to run smooth. So this is something that is of an issue right now. Duplicate development, additional costs on site. We're creating these projects, we're copying segments from the projects, we're making some errors. It's going to cause some issues in the development stages. It's probably also going to cost some issues, or it's going to have some additional cost on site because of the errors that we made. The wire numbers weren't modified properly, the device tagging wasn't identified properly, it's already on site. Now we got to go back on site, we got to go and change that. So all this ends up being a huge pain, and it also becomes a huge cost at the end of the day. So what are we looking at right now? We're looking at a modular principle, a capability of having a certain level of reusability, which is what we are all doing right now anyway. But how can EPLAN help you using that fundamental ideology of reusability? How can it help you to achieve, better engineering procedure and also better documentation? So here we have an example. So right now, to achieve the goal of minimizing your time and cost and maximizing your quality, you have to increase the reusability, and you also have to try to minimize the individual engineering. So obviously, by increasing the reused data, we can now start to minimize the level of engineering that is needed. All right, so this is what we're trying to achieve here. It's also clear that we cannot copy more quickly. So even if we were doing a project and using the copy paste function, there's nothing that is going to make us copy faster, right? It's a Control C, Control V function or a copy paste function, whatever you want. Those processes and procedures, are never really going to get that much optimized. So this is what we're trying to do today. The objective is a high degree of reuse. This is what EPLAN has been saying for quite some time. We've been really marketing this ideology to make people understand that EPLAN is not necessarily a drawing package. We're not labeling it as a draw tool. This is really an engineering tool, and with these functions and features that we're going to demonstrate today, we're going to try to express and show how this is achievable using our tool. So the market is already reusing as much as possible today by copying old projects and post-modifying the old data. So what this means is that we are copying old data and just modifying a few things, right? So that's what we're trying to do here. As you can see today, we're reusing some functions, and we have a lot of individual engineering because there's a lot of manual tasks that come along with all of this. And tomorrow, what we're trying to do is we're going to try to reuse more information, but have less engineering that comes along with it. And this is basically, as you can see from the chart, is going to make things a lot more quicker and smoother. So how could standardization be applied here? So one of the fundamentals that we preach, I guess, if you will, is the capability of using standardized functionality. Now, standardization is a common global term that we should all kind of sort of should be following. When we're talking about different products, when we're talking about different projects and systems, ideally, the more standardized they are, the easier it is for us to make modifications, to do things quicker and easier. That's why these standards and codes are written and so on and so forth. So in this particular case, we have a conveyor system. And this conveyor system has some functions and some infrastructure, of course. So what we're trying to do is we're going to try to demonstrate the approach of in the optimization of the reusing. So the roller conveyor in a whole system composes of 5 functional units, right? So technically you have the component supply, the coarse grinding, the conversion to the second processing, the fine grinding, and then the dispensing and lubrication, right? So here we have, we got the fine grinding that's coming through, and then of course we're going to go into the dispensing with the lubrication and so on and so forth. So these functions consist of additional subunits that are repeated. The goal for today is that we structure this roller conveyor with the help of the IEC 81346 standards and construct this roller conveyor by using different design construction methods, right? Okay, and we'll just move over to the next one here. Okay, so let me just switch slides here. Okay, next. Sorry, just trying to get my next slide going. Okay, so as we mentioned earlier, sorry about that, the roller conveyor system has these different subsections, and what are the most common functions of this? We have common functions or motors, which are not necessarily in the same exact sections. We got motors in different parts of this conveyor system. We got some PLC inputs and outputs. We also have some sensors and actuators placed a little bit here and there. So, okay, I'm going to end the show again. One of these features and functions that we talked about is the standardized functionality. So using standards and codes in the electrical design that we have available right now. So one of those different codes and standards, of course, a lot of people might have heard of the IEC standards. Here in North America, we're using the NFPA standards. If you're doing some fluid design, you got some DIN, ISO standards, mechanical, and so on and so forth. Why are these standards in place? So obviously, these standards are in place for us when we're doing products to be able to follow a certain workflow, a certain functionality, or a certain way of creating these products in a way that we're going to be following certain criteria. A lot of us are using hybrid codes and standards. And what does this mean in the real world? One of the biggest issues that we found is that, of course, these codes and standards are not necessarily being used 100%, and that's completely understandable. A lot of companies out there have been working with these with a hybrid set of standards in their work environment for a very long time, and it's very hard to change. Now, in the real world, when I have a machine and I'm creating this machine based on my company's codes and standards, one of the things that we have noticed is that in the electrical world, if ever your machine, the product that you've created, eventually, hopefully, knock on wood, nothing happens, but it injures somebody, or basically, hopefully, knock on wood again, kills somebody, what we've noticed is that when we are in the court proceedings and we verified that this project, and we're looking at the documentation, didn't necessarily follow the codes to the T, then these companies have the grounds to basically sue. And this is what we're trying to demonstrate here, is that by default, the robustness of EPLANs, and also the fact that we've been in business for over 30 years in 50 different countries, and this is all that we do, those codes and standards are already incorporated by default into the system. So when you're producing your products, when you're creating your schematics and your documentation, you don't have to worry about what code, what standard, how do I use it, how do I not use it. It's already embedded in the system. And in the system, you do have different ways of manipulating the data that it follows these different codes and rules and standards. So this is a great thing for a lot of us, because we're using some tools that were never meant to be necessarily 100% electrical tools. So these codes and standards are not really something that they embed into their system. This is something that EPLAN does. It embeds this functionality into the system. So what we're trying to achieve here is with this standardizations of libraries, this slide that I have in front of you now, what we're trying to achieve here is to demonstrate a little bit like an iTunes playlist. So in an iTunes playlist, if I can use that example, we have different songs which technically are, or different segments of our project, and our playlist will be our end product. So in here, what we have under the library, we have different subunits, and these different subunits, which could be, drive sections, could be PLC sections, could be complex, schematics, power distributions, and so on and so forth. They can have different variations. So they can have variation 1 for a particular, let's say, particular motor, a motor line with fuses, and a variation 2 could be a motor line with an overload. So by creating these different libraries of these macros, and in the EPLAN world, we use a word to express or different blocks that we use, or basically our sections that we're going to be reusing within inside our project, and we call those macros. So these different macros available, what we can start doing inside EPLAN is we can start to create different variations of different sections of a macro. So if we have like I mentioned earlier, if we have a motor macro, a motor line, we can actually create a second, a third, a fourth, a fifth, and up to 16 possible variations for this motor line. Now, what this benefit us when we're creating a project is that with the capability of our macro technology, we will be able to produce our projects very easily, because it's a similar case. What we're doing right now is we're inserting blocks. In EPLAN, you're inserting macros to create project 1, 2, and 3, and so on and so forth. So basically, a little bit what we're achieving here is we're a little bit like the Lego block analogy, where we're grabbing certain blocks and we're creating our end result. So the macro technology permits you to have standardized circuitry, multiple variations of that circuitry, and also associated technical data. So here's an example of what a standard motor circuit would look like. It would have variations, and it would also have technical data. Now, as you can see from the slide in front of you, there is this anchor, which is our associated technical data, which we can manipulate. So technically, if we decide to change the horsepower rating, a whole bunch of things happen in the background. So the cable would change, the amperage on the overload would also change, the wires would probably change gauge as well, and so on and so forth. So this is what we're trying to demonstrate, is by using our macro technology, we are able to achieve this flexibility of reusability that we will be needing for our future projects. Here's another example of a different variation. So I had variant 1, and this would be variant 2. This would be a completely different variant, or maybe a different segment of a project, and so on and so forth. And as you can see, again, I have that anchor symbol that shows up, which is something that doesn't get printed. It's only for our visual use when we're doing our design processes, but it will permit me to change information about a particular element, which in this case, I could change the information about the light. Maybe it's a 230 volt, or maybe it's a 24 volt lamp. I can decide to change that with this associated technical data. Another example here of a standard light circuit variation with technical data. As you can see, visually, if I put this on a schematic, it could represent exactly what it is, but it's the technical data that really changes. So this is something that we can apply when we're standardizing circuitry. Here's another light circuit variation with different data, and so on and so forth. So by having this different variant technology, we have the capability of manipulating all these different elements and to create one big library that we can reuse in our future projects. Okay, so the next method is to what we're trying to demonstrate now is we're going to incorporate to all that we've talked about right now. Is we're going to incorporate the methodology to create circuit diagrams using our tool, the EPLAN tool called EEC1, or the EPLAN Engineering Configuration 1. Now this tool, what will permit you to do is it'll permit you to grab the different macros with the different variants that you have created that reside in your libraries, and it will be able to mishmash it together like a Lego block operation to automatically produce your projects. So the idea here is to use the macros using an Excel file format, and we'll explain why we're using Excel. And we can use this to create our future projects. So this is one huge benefit we have. So what's the philosophy and the intention, and why are we using the tools that we're using, and what does this EPLAN Engineering Center 1, what does it do? So one of the philosophies and intentions is the capability of automating serial letters. So this is the example that we use. We have a Word document, so we have a letter made in Word, and we have an address list created in Excel now, or probably in Word, or maybe in a database of some sort.
Hello, Sergio?
It looks like his audio may have dropped out.
Hello, can you hear me?
Yes.
There you are.
There you go.
Okay, I'm sorry. The phone, I was kicked out by the system. I don't know why. Maybe they didn't like my voice. But can you
No
guys?
problem. We're all good now.
Okay, but I tried to enter the pin, and now it says I'm connected to the audio. Okay, so I guess everybody can hear me now. Can I get a thumbs up from everybody?
Yeah, perfect.
Okay, I'm terribly sorry about that. Of course, we live in an era where issues can arise using technology, so bear with us. Okay, if I may continue, as we were expressing before I got so really interrupted by this system, we have this philosophy and intention of this EEC1 tool that we have to demonstrate today, which is basically using a Word template and an address list, like we mentioned earlier, maybe a database, an Excel sheet, what have you. Using a tool would automatically generate serial letters by grabbing the addresses and placing them into the appropriate sections, creating all these different letters, right? So the automated generation of serial letters. That's what we're trying to achieve. So similar to this, what we're trying to do is how can we use the same fundamental procedure that we just explained, how can we apply it to engineering? So the first things that we can do is that, as you can notice, we have project information. So we have here the project information, which contains sensors, actuators, motors, parts lists, equipment lists, and dimensioning tables, you name it. And of course, we have the standardization environment, which would technically be our macros, obviously what we've explained earlier. So it would be our project templates or reusable functions such as the macros and the different variants and the different associated data and so on and so forth. And we also have like maybe some technical regulations. So if we add these or addition these two together, we can then start to produce automatically generated schematic sheets. So by grabbing the information of the sensor list and the actuator list, the motor list, and so on and so forth, and mixing to that or mapping to that the different macros that are to be used, we can then spit out a project from this. Okay, so that's what we're trying to achieve here. So what we have here is the capability of having a user-friendly and also sustainable means of generating your projects. So we have here the capability of having standardized functionality within the electrical or the fluid or maybe even the 3D panel design. So this is with the variants, the macros, the value sets, the templates, the 3D macros, and the layout spaces that we have. We have this residing in what we call a macro project. It'll all make sense when I demonstrate this to you. Then we add to this the automation functionality, which is basically using the Excel sheet with these sensor lists and actuator lists and motor lists and associating these macros into the mix. And what the EEC1 tool would then at the bottom start to generate project 1, project 2, project 3, regardless if they're completely different, but it will do it in an automated fashion. And this is what we're trying to demonstrate here. So why are we using here, we have the capability of expressing a little bit more what is the use of using Excel. So using Excel functions for rule definition. So this is one of the automated features and that we're trying to demonstrate here, and the cost reduction through configuration. So by using an Excel type of environment, we can start to configure how our projects are going to be generated. So we have the support of the EPLAN automation technology, the value sets, the reports. We can also incorporate scripting into this if we want the system to automatically do some scripts while this is actually running. We have the capability of associating VB programming. So as your company grows, or maybe as your processes grow, you have standardized products. We can create a VB interface inside the Excel environment. With some images, with some checkboxes, with some selectable options that will trigger information that will be associated to the Excel sheet. And of course, with that, we will be able to generate electric and fluid schematics. So the usability, the easy way of use. So why did we choose to go with Excel? Well, Excel is a user is a user-friendly interface. So, and also everybody knows Excel. The drag and drop functionality, which will enable us to grab macros and drag and drop them into Excel documents, a very easy function to use. The rows that we can use inside the Excel sheets that will allow us to make some parameter columns, which we can actually customize. So if we're selecting different horsepower ratings, we can actually do this inside the Excel environment. Graphical macro preview also, as we're selecting our macros, as you can see from the window on the right hand side, I will have a preview of what I'm actually going to be inserting in that particular section. So what you see basically is what you get. Then we have the platform, of course, and since this usability that we have with the electrical, with the fluid, with the process engineering, with the panel design, and so on and so forth, since all these elements inside EPLAN belong to the EPLAN platform, well, this gives us the capability of actually associating, creating not just one type of project. We can actually create very big projects with different subsections that may have electrical, fluid, process, and maybe even some panel design incorporated all into one, and the system will automatically generate all of this for you. So at a glance, what are the values? So we want to provide automation that will fulfill the exact needs of the design processes. We want to use various technologies with various degrees of optimization potential. This is the level of flexibility that we have to offer. Step-by-step changeovers to an automated design processes. If I need to make any changes, I need to do those quick. Increase in the degree of repetition through standardization. Because I have created my elements and my segments in a standardized fashion with different variation possibilities and different data possibilities to be allowed to be changed, this will increase the degree of repetition that I can use. Increase in the quality through specification of defined processes. So we will have a much better and much robust quality of a product. Avoiding common design errors through high repeatability. So by having this standardized and by using a tool such as the EEC1, we will be reducing errors because we'll not be using the old way of creating our projects, which is copy, paste, and so on and so forth. The cost reduction through configuration of partial circuits and projects, and also the benefits of having 30% to 50% cost reduction in design processes. All this is possible using our tool. So let's dive into it. Let's take a look and see what Sergio is talking about here. So what you have here is, we have a project. So this project that you see here is a project that I'm working on. And as you can see, it's a project that's empty. This is the EPLAN Electric P8 environment. And of course, I can start to create some schematic pages and so on and so forth inside this environment. What I'm going to be doing is I'm going to be jumping into the EEC1 tool. So of course, in this particular environment, I have a project that's open. It's live. One of the parentheses I can make, EPLAN is a .NET tool. And by being a .NET tool, can be written into online and offline. So this is exactly what we're going to be doing. We're going to be writing into a project in an offline kind of fashion. So inside the EPLAN environment, what we have is the functionality that we talked about, the EEC1 tool, which is the one that I'm bringing up right now. Inside the EEC1 tool, as you can see, this is an Excel spreadsheet. The Excel spreadsheet obviously has some functions and additional features associated to my EPLAN project that I would be using. In a common everyday process that I would be using to creating these projects, I will start to associate per line what it is, what section or what object I want to insert into my page. And of course, within every object that I insert into my page, there are different properties that I can start to play around with and modify and change. As we mentioned earlier, we have here the capability of inserting macros. So I have the capability, functionality to insert a macro, and I do have the capability of selecting a particular macro, if you will. Here I have, maybe it's a controls voltage, and I have the controls voltage. I have different variation possibilities. So there's a lot of data here that you can see. And one of those sections here, if I look at my power grid, one of the nice features about the EEC1 tool is that when I select what I've actually is already placed, the system automatically synchronizes and shows me what that macro is. And of course, by looking at that macro, I can also see the different degrees of variation. So here I have about 8 possible variations, and I could choose to change that. I can say I want to use variant A, or I want to use it's a single pole, maybe a variant B with a positive, a 24V and a 0V, maybe a variant C, maybe a different possibilities and capabilities that I have to choose from that will be integrated into the system in here, into this line right here. Of course, once it's inserted, once I place that, I will be able to go into the properties and change that here. So, oh yeah, I want to change that to variant A, I want to change it to variant F, and so on and so forth. You have the capability of modifying information once it's already been placed. So of course, as we mentioned, we're just going to grab a line down here. Let's say I want to insert a new page. So I'm going to go here to General, Empty Page, and I want that for my next segment. All I have to do is just grab this, drag and drop it in, and that empty page is going to come in, and I can start to associate information about this page, you know, page name, page information, and additional data that is required. So once you have this placed, once you have selected your macros, associated the different variation possibilities that you have maybe for this one particular macro, given it the information that is required here, you can start to automatically go ahead and generate this. So if I go here and I'm working on this particular section of the project, I got all my information that is already set to go. As I mentioned earlier, inside the project panel, this is an empty project. It's sitting there dormant, and right now I'm looking at that project. So the EEC1 tool right now is looking at my 2.5 project, and I'm going to use my function here, active, to automatically generate the schematics from this sheet. So as soon as I select here, the system is going to go through, and it's going to go placing all those different macros with those page macros, those window macros, those drives, associating the input information for the particular components. And once that's done, now what I can do is I can go back to my project. Here, I'm just going to hit the F5 key to refresh. And now I have a project there. If I double click on this and I open it up, I have some different subsections. So of course, we have 4 sections to my roller conveyor system. And here I can see, okay, this is the motor section. This was automatically generated by the system. I can go to the transport section for the inputs, maybe this the output section. I got some motors as well for different variable information about the motor and what it is. If ever you need to, or you decide to, if I go here, oh, my TS1, those are not the right motors that I wanted, I can always go back to my EEC tool. So I can always go back here to my EEC tool and select here those different drives. So this is the drive that is selected right now. And I want to say, instead of drive A, instead of variant A, maybe I want, say, grab this one, variant C. I want these 2 guys here to be a variant C. So I'm just going to go here, variant C, and I could say here, this one is going to be variant D. It's pretty much the same. I'll say variant B just to be different. I'll say this guy's going to be variant B. And of course, I can change information such as horsepower rating here, 4K, and I can say here, this is going to be a very small motor, and just tell the system to automatically regenerate this. So he's just going to go ahead, regenerate the whole process again, and so on and so forth. The functionality that we're demonstrating here is the capability of exporting the information out and modifying it. So what we're trying to demonstrate here is that we're using the preliminary stages of a project. Once the project has been already created and generated and so on and so forth, what ends up happening next is you will be able to modify the information here. Again, these elements that have been placed, if I wanted to, I can always remove them. I can always replace them. I can always reposition them. I can always go into the individual functions of these particular components and start to make additional modifications manually and on my own. So the system that we're using right now will automatically place all these things for me, but I will still be able to access all these elements separately once they are already placed. Now, of course, what we talked about earlier is the capability of having multiple sections of this project. As you can see, I have various different tabs for the fluid side of things, for the PLC side of things, and so on and so forth. And I got some scripts that were going to automatically generate a PDF and so on and so forth. So all this information that you see here is something that I can also choose to automatically generate the whole project. So here, this function called active was allowing me to generate one section of my project, which is basically one Excel sheet. But using the several function, I will be able to select all the different sections that I want. Maybe I want the overview, I want the cabinet, I want the drives, I want the fluid, I want the scripts, I want all these things to be automatically generated. So I'm going to bring them over to the right here. I have them already set up, brought them to the right. I can reposition these if I wanted to, and so on and so forth. And then again, go ahead and tell the system to generate all of this. So the system is automatically going to go through my Excel sheet, every single one of those tabs, the ones that I've selected, and he's going to automatically go ahead and generate all that. So my project is locked, and that just means that my sheet is open. I'm just going to go ahead, close my sheet, and I'm going to tell the system to generate that again. So there are also in place different check runs available, different sections of the projects that, or different functions of the tool that will permit you to, reduce your errors when you're creating these elements. So there's a lot of integration between what's happening here in the Excel sheet and what's happening in the project itself. So as you can see now, if I click here and I say F5 to refresh, I have a whole bunch of sections. Of course, I have my first title page, so I have project title page, declaration of conformity. I got some higher level structure identifier information about what every single segment of these different structures that I'm using. This is an IEC type of environment. I got the electrical side of things. So here I got my roller conveyor, I got my power supply, my power distribution. Everything has been automatically generated by the system for me without me having to necessarily generate all this or do this manually myself. Now, of course, if you think about it, this whole project that was generated in mere seconds, which is a pretty big project, this is something that we're trying to achieve and demonstrate. And of course, as we mentioned earlier, inside this environment, we do have the capability of associating VB scripting. So here, if I click on the image, I'll have my VB script that gets activated, and I'll have kind of an overview of what it is that I'm trying to achieve for my project. So here, of course, I can start to select here. I want a second grinding unit. I want a power supply. Within my power supply, I want some light power sockets. By selecting these options, what you'll notice is that things are happening in the background. There's things that are being associated. If I go to the roller conveyor sections, I can say here the first one is a 4 horsepower, and of course if I 4 kW, sorry, not horsepower, and if I change it to 3, and I can say here apply, it's going to change the information here. If I want reverse motion, apply. So all these different functions are going to be changing based on this VB interface, and so on and so forth. And of course, once this is all said and done, I can go ahead and tell the system to generate. Now, of course, we do have the capability here. As you can see, I have the capability of generating my Pro Panel environment, and this would be my 3D cabinet. Right now, in the project that I'm working, I don't have any cabinet or any 3D cabinet environment created. What I can do now is inside the EEC1 tool, I can go over and I can bring in my cabinet, which is the panel that I have, which is basically has some wire ducts and some thin rails. And from here, what I can do is I can start to associate some information here. What you notice here in the kind of light green environment, these are every one of those little DIN rails. To the DIN rail, for the first one, I can say I want to associate from the components that are in my schematic pages right now. Maybe I want to place all the protection devices. So I have circuit breakers, overloads, and safety fuses that are going to go on that. On my second DIN rail, I can say here I want maybe some relays. So here I'm going to go to coils, and I'm going to select coils, and I'm going to say OK. So all the coils and relays are going to go on that second rail. And on the third rail, what I can say is I want to associate here maybe some terminals. Maybe I want here all the terminals to be associated, and so on and so forth. And on the last DIN rail, I don't want anything. All right, so that's the way I'm doing my process right now. And of course, I'm going to hit this function here to generate the 3D panel layout. So this level of flexibility and reusability that we have within the tool will permit us to achieve a lot more than just creating typical drawings. We're creating documentation, we're standardizing on the documentation, we're having different variation possibilities, we're even having the capability of auto-generating some 3D panel design. And if I go back here now and I hit my F5, you will notice now that I have a panel section. I'll open this up, and here's my 3D panel that was automatically generated with my components placed. And of course, here I can go into the different sections of my panel, and I could say here, oh, the letters are overlapping each other. It's not a problem. I can go in. It's just a visual thing. I can tell the system, look at it differently, just show me the identification information. And of course, the beauty about having some 3D panel design is that you are able to look at what you're creating and making sure that the components will fit within inside the enclosure that you have selected. So again, in essence, what we have here is the demonstration of how we can achieve automation, if I just created a new word, to achieve projects and achieve standardized functionality. You're going to have a lot more reduction in time and costs and have a better quality product. So from here, what we can do now is we can probably go into, just going to go here, and we can go into our question period. So Leah is with me today. Good afternoon, Leah. And Leah will be letting me know the questions. So what questions can we start to have here, Leah? Do you have any questions for me?
I do have a couple here. And everyone feel free to type those into the Q&A question box, and we would answer them for you as you have any. The first question I have is, how much programming do I have to do to use this product?
None. That's the beauty. It's already been programmed for us for your use. So there's no programming to be done. If by programming we're talking about the setup of the Excel sheet, you do have the typical, which is what I demonstrated earlier, which is the EEC1 tool here. The typical sheet is already been pre-configured. Of course, you can come in here and modify it and change it. If you know Excel, it's basically just a standard Excel sheet. From within the standard Excel sheet, one of the recommendations we have with any of our tools, and with any tool that you would purchase, of course, is to have some consulting. Maybe have one of the experts come in. Of course, most of the people who are going to be using this tool are going to be trained, and within the training, you will know how to create this environment and how to create. This is already pre-configured. All you really need to do is drag and drop your macros into the different rows and associate the data to it. So there's no programming at all. It's a .NET tool, EPLAN. You just install it and you run it.
Excellent. Okay, the next question, what is the overhead on setting this up, creating the new macros, etc.?
Well, to give you an example, and it's one of our success stories that we have, is that we had a customer that came to us and quoted a project in 6 months to be done in a particular tool, and we came in with this EEC1 tool and we did it in 3 weeks. And all we did really within those 3 weeks was basically go through the macros, make sure that those macros were proper, were clean, associatable data to those macros, and then just focus on the Excel sheet, how we wanted to distribute those components and how we want the system to automatically generate that. So what we did is we basically grabbed a 6 months project and we created it in 3 weeks. If you can wrap your head around that, and it was a 1,700 page project, if you can wrap your head around that idea, it kind of gives you a global overview of what it is, the possibilities that we have to offer with this tool.
Excellent. The next question, could this be used with SolidWorks?
We do have, the Pro Panel application does have capabilities of exporting information. So here under layout space, we do have this design space, and we can import and export this design. So I can actually export this file, which is going to generate step files, and it's going to generate a list of positioning or XYZ positioning of where every single one of those elements is to be placed. So we do have a design space functionality. Now this is separate from the EEC1 tool. What would happen in an environment where you want to link this to, let's say, a SolidWorks, well, then you'd have to do it in EPLAN and then export it into SolidWorks.
Excellent. The next question, what software do you have running in the background? There was a 2D and 3D modeling, drafting software, generating the drawings. How did this all link together?
There is no software running in the background that I know of. I just have PowerPoint. I got my PowerPoint, and I got the EPLAN tool. Now, from within inside the EPLAN tool, you have the capability of doing 3D design. But the idea behind all this is that once you have your 3D design, you will be able to create your panels. So you will be able to automatically generate your 2D views. Here, if I can create a model view, I'm just going to call this panel layout. And from within here, I will be inserting a graphic, which is a model view I'll do it real quick here, and I'll say this model view is based on my panel, and this view of my panel, I want it to be, let's say, the mounting plate. I wanted hidden lines, I want a front view, and I want it to fit the little box I created. So the 2D environment is automatically generated for you by the system. I didn't do any drawing here. This is also being automatically generated from here. I modify, I change anything here, my 2D view will be updated.
Excellent. Do you require EPLAN to review or work with archived files, record drawings?
I don't really understand the question, but archiving files, we have PDF functionality. So the PDF that gets generated from EPLAN is a smart PDF. The PDF, we can actually go into the PDF and modify it, and we can actually import that information back. So here on their page, I have the capability of importing the PDF comments that were made inside the PDF environment. So if I need to redline or do any of those applications, I don't have to have EPLAN open. I can just go right through with the PDF using the regular Adobe Reader, making some markups, and then importing that information into my project. I can do that with EPLAN.
Okay, perfect. Can this work with an output to a CAD file?
Yes, we can obviously, once our schematics are done, we can obviously export to a DXF DWG. When you do the export to DXF DWG, you will have the capability of having all those block attributes that come through. And you can also specify some block definitions. You can map fonts and layers to any CAD type of application.
Perfect. Okay. Someone is asking, is the pre-planning module needed for EEC1? And are the macros in EEC1 with the same functionality as in pre-planning? How are they connected because they seem similar?
The pre-planning function is not necessarily something that is needed because inside the, if you will be doing the pre-planning functionality for the process and PNIDs and so on and so forth, you can have, those are associated to macros. Now the pre-planning tool is something that you can incorporate because it's part of the platform. Inside the EEC1 tool, what we would be doing is we would be generating those planning objects. Once we have generated those planning objects, then from those planning objects we can start to create our schematics. The EEC1 and the pre-planning tool kind of resemble each other, and for this to go into a lot more detail about the pre-planning functionality, I would highly recommend whoever is interested to maybe contact us and we can have a presentation, a demo, and discuss this further. But you don't need to have the pre-planning tool necessarily. You can all you really need is the electric P8 and then the EEC1 to start to generate schematics.
Perfect. Okay. We have a question about how much training is required for this.
The training that is required is one of the benefits of having a tool such as EPLAN is that it's a .NET tool, which means it's basically a Windows tool. There's no coding, there's no scripting, there's no extensive library of words that I need to remember about different commands and so on and so forth. It's drag and drop, it's mouse functions. If you know how to use Outlook, if you know how to use the internet, you should be able to use EPLAN. In the training, what is involved is that we're going to show you where these functions reside. I want to generate a report. I don't know how. All right, so you have to go under Utilities, Reports, and then you hit Generate. Inside that, what do you want to generate? What kind of report do you want to do? Okay, well, I want to do a page or a manual. So these are the kind of things that we go through with inside our trainings, and this is basically the level of time that it would take. Now, we do have some basic trainings in place. We have some advanced trainings in place. We have some separate trainings for the EEC1 tool, some other trainings for the Pro Panel tool, and so on and so forth. So to the level of your expertise that you want to achieve, we have the different trainings available for you.
Excellent. Another question, are you able to create your own custom macros from scratch?
Oh, of course. At any point in time, I can go ahead, I can insert symbols. Here's my electrical thing here. Just switch that over, and I could say here, I don't know, I'm just going to grab some 3-pole fuses. I'm going to grab that, connect that there, and I'm going to grab maybe here, I'm going to grab some motors, let's say, I don't know, some motors, position that here, and then I'm going to grab this, and I'm going to right-click here, and I'm going to say create window macro. Give my macro a name. Of course, here I'm going to call my macro, I don't know, Sergio, because I love my name, macro motor. And once that's created, what I can do now is I can go back into this, insert my macro, my Sergio macro is there, hit it, and then I can go ahead and place it and use it. It's a very easy way to create macros. And of course, as we mentioned, they're all separate. Like they were created together, but I can always split them apart at any point in time.
Excellent, perfect. Someone has asked, can we receive documentation and web-based info regarding additional info about this tool? Yes. I think that actually we probably, if there's a few more questions, but I've had several questions that have come in about things like pricing, where to find the training information, as well as further demos that you would like to have done on, for instance, the other tabs in the EEC1 tool, configuration tool. With that, you can reach out to us here via our website or the info@eplanusa.com. And at that point, we would be able to get any of those things set up for you via account managers in your area, getting a technical representative to do a demo for you, things of that nature. So hopefully that will help some of you out. I think that actually that is about all of the questions. I think we covered just about everything. Like I said, for information on pricing, training, things of that nature, we would need an account manager to reach out to you for that. So hopefully that would cover that information. And again, you can do that via either our website or the info@eplanusa.com email. I think other than that, I think we could pass it back over to you, Kevin.
Great, thanks a lot, Sergio and Leah. That was a great presentation. And I see that the audience really enjoyed it, and they really enjoyed your webinar. So thanks a lot, Sergio.
Thank you, everybody.
And just a reminder, if you did want to view the recording of this webinar, it will be available on engineering.com shortly after the live webinar. And thanks once again for joining us today for the webinar. Have a great day.
Thank you. Bye-bye.
Bye-bye.